Yo, 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 Algebra 2.1. This is the last lesson for this week. It's actually not even a lesson. It's just a Desmos activity. But before we do that, let's go through bell work, homework quiz for piecewise function. I want to review at least 4 questions out of your 5 questions on the homework quiz. I'm going to review 4 questions for piecewise functions to make sure we definitely have it. And 4 of those questions are going to have the same process, maybe even the same numbers on the homework quiz. After that, we're going to go through the what's my transformation for Desmos activities so that we can kind of adequately see and make the connections between graphs, transformations, domain and range, and as well as piecewise functions. We're going to do all of that together, and then finally the summary, closure, homework. Let's get started. Let's go through these 2 questions right here for your bell work. I'm going to go through it pretty fast, okay? Pretty fast, speedy lightning. So first thing I notice is 2x minus 4. I'm actually not going to do as much writing here, okay? 2x minus 4, because I know 2x minus 4 is this. Now watch another thing while I'm thinking. 2x minus 4, you can just graph this. What's 2x minus 4? Your slope is 2. Your b is negative 4. Watch what I do here. I'm going to do it a different way than what I did in the video. So this is going to be negative 4 right here, okay? And then you're going to go up 2 over 1, okay? And then up 2 all over 1. And let's go a couple down, like down 2 all over 1, and then down 2 all over 1. Okay, so your graph, I'll use my actual straight line, my straight line one. If I can try to pinpoint where it's going to be. Not that. Let me try to guess this. Oh, that one's pretty good. But I don't like it. So I need to kind of get like, ooh, yeah. That's amazing. Look at that. Boom. Okay. Now here's the problem. Now, obviously, this is the line, right? Here's the problem. It's restricted. Okay? That's the issue. It's restricted. So since it's restricted, where's it restricted at? It's restricted right here. So it cannot be greater than negative 1. It has to be less than negative 1. X is less than negative 1, which means right here is where negative 1 is at. So that means my graph goes from here down. So what do I have to erase? I have to erase literally from negative 1 right here. So this negative 1 from here, okay, all the way across. Now, of course, I have to also erase the dots as well. So that right there is where my graph is. I had a couple of students ask, like, couldn't I just do that? Like in the past, they've asked, like, can I just graph the whole thing and then just cut it off, like what I don't need? And like, yeah, absolutely. You can definitely do that. And if that helps you, go do that. Like, that surely should help you. Right here is negative 1. I want it less than negative 1, so I just need that piece. As long as it's dotted and that's a full dot, it's close, then we're solid. Now let's do the other one in blue. So this one is greater than negative 1, but my slope is negative 1. My b value is 1. Okay, so my b value is 1, so right here. Okay, and I'm going to go down 1 all over 1. Okay, down 1 all over 1, down 1 all over 1, down 1 all over 1. It's a negative slope. And let's do a couple more. Now, we can either cut it off right here, or we can know, like, okay, well, it's going to be right there. And yes, I know it's got to be right there, okay, because that's where it lines up. But let's just say, you know, we did the line, okay? So we did the line. We get blue. Ooh, I'm getting really good at that. Look at that. That's amazing. We did the line, and of course, we know it's less than, or sorry, it's greater than negative 1. So since it's greater than -1, I need to erase everything right here, okay, from -1, because this is where it's at, guys. Here, -1's right here, right? So I need to erase all of that, right? So how do I erase all of that? Well, just by erasing it. So you go erase, 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 erase. So right there. Now I did it a little bit past, so I need to make sure I extend it. Okay? And that's what my graph will look like. I think that's pretty awesome. That's pretty solid. What will my domain and range look like? My domain right here is -infinity to +infinity. Most of your ranges, most of your domains will be like that. I know that because that continues, and it'll always continue. Look at our notes from yesterday and you'll see -infinity to +infinity. Notice I read it left to right. Now, bottoms up for range, it does exist down here, so I'm going to say -infinity, but where does it stop existing? It stops existing right here, okay, right there at the 2 spot, so this 2. So right there at the 2, I'm going to put 2 and then parentheses. Okay? Awesome. And that's your domain and range. Okay? Sweet. Now, let's go to the next one. I'm going to erase everything. Let's go to the next one. So in blue, we got this. I went through this in the notes as well, but let's just do it really quick. That's -1, and that's going to be less than 0. So -1 right here, and then less than 0, less than or equal to 0. So it's actually going to be a closed dot all the way over. And then this one is going to be an open, or sorry, another closed dot. Wow, another closed dot at -7. So another closed dot, but not at 0, but at 1 right here. And it's greater than, so that means it's going to go this way. Now, what is my domain? My domain is kind of finicky. Okay, reading it left to right is -infinity. Actually, you know what? I'm going to color code here for you. Just cuz. Watch what I do here. Follow my color code, blue and red. -infinity to 0 bracket. Okay, and then union. What's in blue corresponds to the blue graph, and then bracket 1 to infinity. And what's in red corresponds to the red graph. So this is the 1 comma infinity here. Okay, and this is the union. All right, so that is my domain. And then I'll just keep it as red. It doesn't matter. What's my range? My range is a little bit also finicky. Okay, because it doesn't exist here, it doesn't exist here. It exists only at one number, and that is -7. It exists only at one number, and that is -1. Notice my y values. Okay, my y values are -7 and -1. So what those y values are will be my range literally themselves. I don't need to do any other thing besides the braces. Now, on Math Excel, they'll have the braces there for you, so don't put the braces. They'll have them there for you, but that is my range. Okay, just put -1, -7. Okay? I hope that makes sense. I hope that I've explained that thoroughly enough. I already did this problem twice. Look back at the notes from the previous day. Let's erase and continue. So, I got this question right here. This is another question we went through our notes. Basically, it's evaluating if this is -1, which function am I going to plug it in at? Well, this is the restrictions. Am I going to plug it into the function that says greater than 0 or less than 0? Well, look at your x. You're going to plug it in because -1 is less than x. You're going to plug it in right here. You're going to plug it in here because your restriction says x is less than 1 and -1 is less than x. Okay? Or less than 0 because -1 is less than 0. Okay? You're not going to plug it in here because -1 is not greater than 0. But it says here that x is greater than 0. Your -1 is your x. Okay? So, again, -1 is either greater than or less than 0. You'll say, it's less than 0, Mr. Carlson. Great. Plug it in this one where it says less than 0. So what does it look like? It looks like this. You plug it in, and negative times a -1 to the 5th power. And then this is going to be plus, and then -1 to the 4th power, and then plus 30 times negative. Oh my gosh. This just looks awful. 30 times negative 1 and then negative 30. Okay? This right here is actually just a negative to negative 1. This is going to be a positive 1, minus 30, and then minus 30. And then this becomes a positive positive. So that's 1 plus 1 minus 60. Actually, no, I can't do that. That's not order of operations, Mr. Carlson. You're right, kids. You're right. Okay, 1 plus 1 is 2. Minus 30, minus 30. And then this is negative 28. Minus 30, and then this is finally negative 58. I just want to see if I did everything correct because I did that pretty fast. That's still negative, that's positive, that's negative, negative. Should work. Good deal. Awesome. So that's how you do that problem. This one is kind of a blast from the past. It's actually still on your homework quiz, by the way. This one right here, it's on your homework quiz. But it is a functions. Okay, it's about functions. And notice how this is a piecewise function. So I thought it was nice to kind of put the two and two together. Determine the domain. What's the domain here? It is, of course, negative infinity to positive infinity. What's the range? The range is negative infinity, and it stops right here at which value? From bottoms up. Where does it stop? Negative 4. And is that included? Yes, Mr. Carlson, that's included. Perfect. That's your A value. Your B value is this, range, and then your C value is the x-intercept. Is there any x-intercepts? No, it doesn't cross it. So you're just going to say none. Okay. What about D? Is there any y-intercepts? Actually, yes, there is. Right at negative 4. That same point, right? So negative 4, boom. Okay. And then the function values. What are the function values? So we're going to look at two function values here, negative 1 and then also 4. So negative 1 is right here. Go down. Where does that hit? It seems to hit right at negative 5. So that means this one's negative 5. Now let's look at 4. Where does it go down? Seems to hit right at negative 4, right? So this one is negative 4. That is how you do that problem. Boom. I know I went through that fast, but that one is technically review, and it will be on your homework quiz. So make sure you review it adequately enough, go through your homework, ask questions before, pop onto the Google Meets if you need to. I'm going to race. All right, so your homework quiz is 25 minutes, 5 questions. Of course, you can use your notes. When finished, please just review your answers. This is definitely a partial credit kind of homework quiz where you have like parentheses, brackets, negatives everywhere. Like you can definitely get confused. All right, so please send any partial credit if you need to. And then begin on your homework assignment. What's your transformation? What's my transformation? I will say this for what's my transformation, this Desmos activity. I will probably extend it till Monday, but I would like it to be due by 4 p.m. All right, please go to student.desmos, type in that code. Let's get started. I'm only going to go through a couple of slides with you guys. Just a couple. It loads. Awesome. Again, student.desmos.com. Go here, or you can just go to the next slide and then click on that, and that will actually take you straight up to just the Desmos activity. Okay? But I'm not a student, right? I'm the teacher. So make sure you get the code down. Let's go through them. Awesome. All right. These are lines. Perfect. These are lines. Actually, there's only one line in the world, and we just move it around to make new ones. And that's true. That's true, guys. I need you to understand that. There's technically one line in the world, and we just move it around to make total new ones. We move it around constantly. Convince yourself this is true by moving these points. I can move these points however I want, right? And I can try to match them. Like, oh my gosh, I can actually try to match these? Yes, you can. Oh wow, I can match them. okay? I can match that, right? What about this one? Let's try to match these. Well, that seems to be working out pretty nicely. And then, of course, I can match this, right? Boom, roughly, pretty good, you know? So that's lines, and now as we kind of go through this, you'll see a next function, it's parabolas. These are parabolas. Parabolas are amazing, okay? I love parabolas. We're going to have a whole unit on parabolas, unit 3. So please move this around as much as you need to kind of convince yourself that this is, wow, these are the exact same things, okay? And we're just really transforming these parent graphs, right? That's really what it is. Okay, we're transforming these parent graphs around into making new functions, okay? So if I did here, and I move that, I can make it skinny like this, or I can make it really, really fat like that, and that is technically a parabola. Okay, that's a parabola, even though it's fat. Okay, fat parabolas are parabolas too. All right, same thing as skinny parabolas. I can make it really, really skinny. Skinny parabolas are parabolas too. Okay, now these are weird kind of function. They're called parangulas. 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 Okay, very funky. Very, very funky. Parangulas. I can move it, kind of switch it around. They're nice functions, and they actually kind of look like our piecewise functions. Yeah, because everything's starting to match. Again, we're in the unit of equations and functions, guys. We're looking at functions, and we're looking at equations, and we're putting them together, and we're trying to make graphs out of them, right? Yes? Pretty cool stuff. Now, what you're going to see here is it doesn't even work, so don't even try. You cannot transform a parangula into a parabola, nor can you do a line. So you can't even try to transform a parangula into a line. Now that gets pretty close. Let me try. Like that gets amazingly close. But try to get this together. Can you try to do it? Maybe some of you are like thinking, I can do it. Okay, maybe I can do it. I can do it. It's like, oh, it's really close. Yeah, it's not going to work though, and that's the problem. So I can maybe try that. I can move it, and like, oh, that's close. That's really, really close. But you see, it's no cigar. It kind of breaks off, right there. So moving on, we see that we want to drag the parangula so it matches the orange one. This is what we call, right here, this is what we call the shift, right? This is what we call the horizontal shift. How many units, when I transform this, guys, does it matter the equation? No. How many units does it take for me to do here and to get to here? How many units did that black dot move? You should be thinking quattro, okay? To the right. Now, this is when you start seeing like symbols here, okay? So you move the original parangula 4 units to the right by dragging it across the screen. Now, the original parangula is a graph of a function called f of x. Do you need to know the actual numbers into this parangula? No, I don't care. But look at this. You can do the same thing by typing f of x minus 4. So f of x minus 4. And that will actually give me the same thing. You can make the same move by typing this, and I can submit it. And then boom, it moves. What do you know? Now, what if I do, now watch this. Watch this. I said x minus 4, right? Some of you will be thinking, well, it moved to the right. How is that possible? Watch this. If I say plus 4, is it going to move to the right? It's going to move to the left. But watch. What if I do, okay, plus 4, and then plus 4? And then you're probably thinking, okay, fine. If it's kind of mixed, plus means left, negative means right. Okay, so that means plus 4 off to the side. That's going to mean down, right, Carlson? You're wrong, okay? It actually means up 4. So this is something that transformations of functions is very interesting because if I do minus 4 now, it's going to mean down 4. And if I just do, watch, if I just do x and then minus 4, it goes down. But then if I just do plus 4, it goes up. So this seems like this, we're trying to get used to transforming functions. Okay, we're going to transform some of these functions here. So now in the next slide, I want you to try to do at the best of your possibility, the best that you possibly can, do and transform these. I'm going to do the first two for you. So on red, how can I get the black to here? Now look at this, 0, 0. And now this is 3, 0. So I want to do the red. So that means what I want to do is transform it to go to the red. Okay? And boom, there it happens. There I did it. How did I do that? Well, I did it because I did minus 3. Now what if I want to do the orange? Okay, actually, I'll do the green here. I'll do the green. Now 0 to here, I clicked like the vertex of it. 0 to negative 4. Look at my range. So I do green, and watch this, f of x, okay, watch, minus 4, and then I get the green, okay? Now notice how this is inside the parentheses, the x minus 3, and this is outside of the parentheses. So play around with it, see if you can get the orange and the blue, okay? Play around with it, see if you can get the orange and the blue. Now, take a moment to take some notes about how you moved around, what symbols you use, what's the difference between the negative and the parentheses, and the negative outside of the parentheses, or the positive in the parentheses, and the positive outside of the parentheses. Take a moment and kind of do that. And now what we're going to be doing is kind of stretching. So this is kind of the stretching thing. I love this. Okay? So I'm going to try to get it really, really close to it. That looks pretty good. Right there. Oh, I was a little off. Boom. Okay. So that is stretching the parangula. Okay. Now stretching the original parangula for a factor of 2.1. How can I do that? Well, if I type this in, 2.1 times f of x. That's what I get. Now what if I do 1/2, and then times f of x? What happens here? Now what if I do 10 times f of x? So it seems to, like, when the higher the number I go, the skinnier it gets, but the smaller number I go, so 3 f of x, kind of the fatter it gets. Let's do like even a huge fraction, f of x. Wow. What about 16? F of x. Okay. Now let's do 256. Watch what happens here. Okay. 256. It becomes almost a straight line. Almost a straight line. That's pretty crazy, right? And then what if I do 256, and then times f of x? Look at that. Just stretched up like stretchy pants. I mean, yoga pants all around. I'm telling you. Okay? So it's really, really interesting to see how this works when you're stretching your any graph. Now we're just using what we call a parangula, but it's really any graph. You can shift it, you can change it, move it however you want. You can do it with parabolas, you can do it with absolute value functions, you can do it with lines and so forth. So it's really awesome. Now I'm going to do just one of these for you. Okay? I'm going to try to get the red one. Okay? Now I see the red one and it's shifting up. And this honestly has to do a little bit of trial and error. But since it's a little bit skinnier, notice it's a little bit, the red is a little bit skinnier than the black, which means I'm going to do maybe a number like 2. Okay? And then f of x. And I'm getting closer. So what if I do like 3 and then f of x? Ah, boom, there it is. Okay? So play around with the orange and the blue, see if you can get it, and then afterwards take a moment, summarize your findings. Now put it all together. I want you to do this one completely by yourself, put it all together, and see if you can kind of get these. Okay, see if you can kind of get these together. The tricky one is the blue, so watch out for the blue. I'll give you a hint. You may need a negative. You need a negative in there. And so use that negative as a guide, and then because it's reflective, use a negative as a guide and kind of shift it around. How many times does this shift down over here? And then what do I need to kind of put it together? Okay? Try to do it yourself. Try it. See what happens. Put them together. Okay, Malcolm says that the blue perangula is a reflection over the x-axis. Is that true? Who is correct? Because Jamal says that the blue perangula is a vertical stretch. Figure it out. So that's the whole Desmos activity. I pretty much went through the whole thing with you. That's amazing. Guys, this was the whole week. We have one more week of our first unit, and then we finish it up with a nice fat test, 20 questions, 100 points. Okay, so finish this up. Hopefully it's done by 4 p.m., but if you need to take the weekend, I won't mark it late. Otherwise, it's going to be due by 8 a.m. on Monday. Guys, it's been a blast. This is C Squared Mathematics. This is Mr. Carlson. See ya.